Welcome to Career Guidance Max playlist. In this video, I am going to explain type 2 non-symmetric matrices with repeated eigenvalues based on problem. So here I taken the matrix minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. So I am going to consider this matrix is A. Minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. So first I am going to find the characteristic equation. The characteristic equation the given matrix is 3 by 3 matrix. So I am going to apply 3 by 3 matrix characteristic equation. Lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. So now from this characteristic equation I'm going to find what is S1, S2, S3. So S1 is represent trace of A. Trace of A is nothing but we have to add all the diagonal elements. Sum of the diagonal elements here minus 2, 1, 0. I'm writing minus 2 plus 1 plus 0. You will get S1 is equal to minus 1. And next I'm going to find S2. S2 equal to sum of minus of the main diagonal element. That means based on diagonal element we have to find minor values. Here we will take first one minus 2. Based on that I am going to find minor. So this row, this column omit, remaining you can write as a determinant form 1, minus 6, minus 2, 0, first one, and plus second diagonal element 1 based on this minus 2, minus 3, minus 1 and 0. Third diagonal element 0 based on this minus 2, 2, 2, 1. So simplify this 0 minus 12 and plus 0 minus 3 and plus minus 2 and minus 4. So that we will get minus 12, minus 3 and minus 6. So therefore S2 equal to minus 21. Okay. S2 equal to minus 21. Now I am going to find S3. So S3 equal to determination of given matrix A. So I am going to substitute determination of minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. So apply the determination rule for 3 by 3 matrix. So minus 2 of 1, 0 and minus 12 and minus of 2 into 0 into 2 0, minus 1 into minus 1 plus 6 and minus 6 and plus minus 3 into minus 4 plus 1. So simplify this minus 2 into minus 12, here minus 2 and minus 6 and here plus minus 3 into minus 3. So you will get plus 24 and plus 12 and plus 9. So 24, 12, 9 is S3 equal to 45. Now we know the values of S1, S2, S3. I am writing the characteristic equation. Lambda cube minus S1 lambda square. Here S1 is equal to minus 1, so plus lambda square and plus S2 lambda. Here S2 is minus 21, I am writing minus 21 lambda and minus S3. S3 is here 45, I am writing minus 45 is equal to 0. So next I am going to find eigenvalues. By solving this characteristic equation, we will get eigenvalues. So the characteristic equation is in the form of cubic equation. So we have to apply synthetic division method. Lambda cube coefficient is 1, lambda square coefficient is plus 1, and lambda coefficient minus 21, and the constant term minus 45. So here we have to substitute the values 1, minus 1, plus 2, minus 2, plus 3, minus 3, like that. So if you want to start with 1 now, you have to substitute 1, lambda is equal to 1 in your characteristic equation. So both side it is equal means that is will be 1 root. We have to do like that. That is our usual procedure to finding the root. But here last term will be 45. If you are taking 1 now, it is not possible because here 21. You won't get 1 and minus 1. When you are taking 2, 2 is even number. Multiply with the odd number, it converted to even. So here you will have 45. It's not possible. So the only the thing is, we'll start with the 3 or minus 3. So here both the terms are minus. So I will continue with the minus 3. Alternate you will get plus. So 1 plus 0 is 1. Minus 3 into 1, minus 3. 1 minus 3 is minus 2. Minus 3 into minus 2 plus 6. Minus 21 plus 6 I will get minus 15. When multiplying this 2, minus 3 minus 15 I will get plus 45. So it's equal to 0 you will get. So that one root is lambda is equal to minus 3. This term I am going to write as a equation form. 1 I am writing lambda square. Minus 2 I am writing minus 2 into lambda, and minus 15 is equal to 0. So this one I am going to write minus 15. Which two number gives minus 15? Which two number when we add it gives minus 2? According to that we have to take the numbers. So for example I will take here 3 and minus 5. Multiply these two, you will get minus 15. Add this 2, you will get minus 2. So that I am writing lambda plus 3 and lambda minus 5. We converted quadratic equation into linear factor. Now equating to 0, you will get lambda is equal to minus 3 and lambda is equal to plus 5. So therefore the eigenvalues are lambda is equal to, already we know one value minus 3, and here also minus 3 and 5. So which is repeated eigenvalue model. Okay. So based on these eigenvalues, I am going to find the eigenvector. So the eigenvector, the formula is A minus lambda I into capital X equal to 0. This A is represent the given matrix, that is minus 2, 2, minus 3 and 2, 1, minus 6, minus 1, minus 2, 0. This is our given matrix. And minus lambda into I is identity matrix, depend upon our given matrix. Here given matrix is 3 by 3, so I will take identity matrix also 3 by 3. G1 0 0 0 1 0 0 0 1. This x I am going to write small x1, x2, x3. This is only we are going to find the eigenvectors is equal to 0. And now you can multiply second matrix with the lambda. Minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. First matrix, and minus multiply with lambda, you will get lambda 0, 0, 0, lambda 0, 0, 0, lambda into x1, x2, x3 equal to 0. Now I am going to subtract these two matrix. So minus 2 minus lambda, I will write minus 2 minus lambda. Here 2 minus 0 as it is 2 minus 3 minus 0 I will write minus 3. And similarly second row 2 1 minus lambda and minus 6 and minus 1 minus 2 0 minus lambda minus lambda. And I am going to multiply with the x1 x2 x3 equal to 0. I am going to multiply these two. First matrix I am taking row wise, second matrix I am going to take column wise. Based on that we can able to form a equation model. So minus 2 minus lambda into x1 plus 2 into x2 and minus 3 into x3 is equal to 0. First equation. And then 2 into x1 1 minus lambda into x2 minus 6 into x3 equal to 0. Third row minus 1 into x1 minus x1 minus 2 into x2 minus 2 x2 minus lambda into x3 will write minus lambda x3 is equal to 0, which is I am taking general equation number I, or your convenient you can choose the equation number I 1 2 3 like that. So from this equation I am going to substitute our eigenvalues. Here our eigenvalues are lambda is equal to minus 3 and 5. So first I am going to apply different eigenvalues, non-repeated eigenvalue. So that is put lambda is equal to 5 in the general equation I. So I will substitute here lambda is equal to 5, minus 2 minus 5 minus 7 x1 plus 2 x2 minus 3 x3 equal to 0, which is equation number 1. In second equation I am going to substitute lambda is equal to 5, 2 x1 1 minus 5 minus 4 x2 minus 6 x3 is equal to 0, which is equation number 2. And next equation I am writing minus x1 minus 2x2, and here I am substituting lambda equal to 5. I will get minus 5x3 equal to 0, which is equation number 3. So first always we have to substitute different eigenvalue. You will get one eigenvector based on that. So before going to find that eigenvector, after substituting lambda equal to 5, we will get these three equation. This three equation is system of linear equation. After that we have to check whether it is the same or different equation. When we are checking these equations, these are different equations. So that from this I am taking first two equation from 1 and 2. I am taking equation 1 and 2. I am going to find eigenvector of x1. So by using cross multiplication method, that means cross rule method. We can apply only cross multiplication method when we have different equation. Otherwise we cannot able to apply cross rule method. Okay. So here I am writing x1 and x2 and x3. Based on equation 1 and 2, I am going to find this x1, x2, x3. So if you want to find x1 from that both the equations, you can omit the x1 coefficient. Remaining you can write as a determinant form. 2 minus 3 minus 4 minus 6. Next I am going to find x1, x2. So here first you write x3 coefficient, that is minus 3 minus 6. After that x1 coefficients from the both the equations, minus 7 2. And x3 means omit x2 x3 coefficient. Remaining you can write in a determination form of x1 x2 coefficients, minus 7 2 2 minus 4. And simplify this, x1 divided by 2 into minus 6 minus 12, minus 4 into minus 3 plus 12, formula minus 12. And here x2 divided by minus 3 into 2 minus 6 and minus of minus 6 into minus 6 plus 42 and equal to x3 divided by minus 7 into minus 4 plus 28 and here 2 into 2 4 minus 4. So I am writing x1 divided by minus 24 and x2 divided by minus 48 and x3 divided by plus 24. So I am going to divide it by commonly minus 24. We will get x1 divided by plus 1, x2 divided by plus 2 and x3 divided by minus 1. So which is your first eigenvector? The eigenvector capital X1 equal to 1, 2, minus 1. This all small x1, x2, x3 you can write column wise. 1, 2, minus 1. Is this your first? So now I am going to find second eigenvector based on eigenvalues. So in this problem we will have repeated eigenvalues and one non-repeated eigenvalue. Based on non-repeated eigenvalue we find eigenvector 1. Now I am going to find eigenvector 2 based on repeated eigenvalue. I am going to substitute the repeated eigenvalue lambda equal to minus 3 in equation I. So when I am substituting here lambda equal to minus 3, minus into minus plus 3, minus 2, I will get x1 plus 2x2 and minus 3x3 is equal to 0, which is equation number 4. Next, in second equation I am going to substitute lambda equal to minus 3, I will get minus into minus plus 1 plus 3, 4. 2x1 plus 4x2 minus 6x3 equal to 0, which is fifth equation. In third one I am going to substitute a lambda equal to minus 3. So I will get a minus x1 minus 2x2 minus and minus plus 3x3 equal to 0, which is equation number 6. So after that usually we are applying cross rule method, right? But the system of linear equation, first we have to check whether it is different or same equation. So first one we will have x1 plus 2x2 minus 3x3 equal to 0. In that second equation I am taking 2 outside. That means we will get x1 plus 2x2 minus 3x3 equal to 0. So it is same. In that last equation I am taking minus outside. I will get x1 plus 2x2 minus 3x3 equal to 0. That means these three equations are same, so we cannot be able to apply cross rule method. All the three equations are same. So we cannot be able to apply cross rule method. I'll take this equation x1 plus 2x2 minus 3x3 equal to 0, which is equation number 4. From this equation 4, I will put x1 equal to 0. If I am substituting x1 equal to 0, I will get 2x2 in equation 4. 2x2 minus 3x3 equal to 0. This minus 3x3 you can shift to right hand side. You will get 2x2 is equal to 3x3 and cross multiply the term x2 divided by 3 and x3 divided by 2. Okay. Now I am going to write the eigenvector of second one. The eigenvector of second one x2 I am writing. Already we know we considered x1 equal to 0 and x2 is 3 and x3 is 2. Use this for second eigenvector. So second eigenvector we identified based on lambda equal to minus 3. When I am substituting lambda equal to minus 3, we will get the system of equations. All three are same. All three are same means we cannot able to find based on cross rule method. So here we taken any one of these equations. We will put x1 equal to 0. We will get a x2 eigenvector. In similar manner, Case 3. In case 3, we'll consider equation 4, x1 plus 2x2 minus 3x3 equal to 0. Here I am going to substitute x2 equal to 0. Already we taken x1 equal to 0. Now I am going to substitute x2 equal to 0. So that means x1, this one 0, I will get minus 3, x3 equal to 0. And I am writing x1, shift to right hand side, you will get 3x3 and cross multiply the term, x1 divided by 3 and x3 divided by understood 1. So when I am substituting x2 equal to 0, I will get x1 equal to 3 and x3 equal to 1. I am writing the third eigenvector. x3 is equal to x1 3, x2 0, x3 is 1. So when you are substituting repeated eigenvalue minus 3, your system of equations are same, means while finding eigenvector x2, you can substitute x1 equal to 0. You will get one eigenvector. Again, if you want to find x3 eigenvector from that equation 4, again you can substitute x2 equal to 0. You will get third eigenvector. That is the procedure we have to follow here. So just I will recall what we completed in this video. So here I taken one 3x3 matrix. I am going to solve this model based on symmetric matrices with repeated eigenvalues. I am going to find eigenvector and eigenvalues. Okay. So 3x3 matrix means we have to take characteristics also like this: lambda cube minus s1 lambda square plus s2 lambda minus s3. From that we have to find s1, s2, s3. s1 trace of a, s2 sum of minus of main diagonal element. Based on diagonal element we have to find minor values, and s3 we have to find in determinant form of given matrix A. You will get s1 equal to minus 1, s2 equal to minus 21 based on that. And the third one s3 equal to determination of A, that is also 45. All those values we have to substitute in our characteristic equation. This characteristic equation in the form of cubic, we cannot able to factorize directly. So while finding eigenvalue, I will use synthetic division method. I will take minus 3, it gives 0. So one root is lambda equal to minus 3. This 1 minus 2 minus 15 I am writing as a linear analytic quadratic form. 1 is lambda square minus 2 into lambda minus 15 equal to 0. Here I converted this as this into linear factor. Linear factor lambda plus 3 lambda minus 5 equal to 0. So I will get lambda equal to minus 3, 5. The eigenvalues are already we know one value minus 3. Now we identified minus 3 and 5. So eigenvalues are lambda equal to minus 3, 5. Here we have repeated eigenvalues minus 3 and one non-repeated eigenvalues, different one. First we have to find eigenvector based on a non-repeated 5 eigenvalues. So the procedure of finding eigenvector is a minus lambda I into capital X equal to 0. End of this you will get this equation. From this equation I am going to substitute 1 by 1 lambda is equal to 5. When I am substituting lambda is equal to 5, I will get 3 different system of linear equation. If we have a different equation, we can able to apply cross multiplication method. Take any two equation and apply cross multiplication method, you will get this eigenvector of 1, 2, minus 1. So next I am going to substitute in that system of equations repeated eigenvalue lambda equal to minus 3. When I am substituting lambda equal to minus 3, I will get 3 equations. That 3 equations are same, means we cannot able to apply cross rule method. In this case, take any one equation and this is repeated eigenvalue. So the procedure, first I am taking x1 equal to 0. When I am taking x1 equal to 0, I will get eigenvector of x2. Repeated eigenvalue means again third eigenvector we can find based on x2 equal to 0. We have to substitute in our equation. When I am substituting x2 equal to 0, I will get third eigenvector. So that is the procedure we have to follow. So in this type 2, we solved only one problem. Remaining problems you have to practice yourself, but I'll tell you what are all the procedures we have to follow while finding eigenvector. For example, first one, already you know that you will have lambda is equal to, consider this problem, -3, -3, 5, right? First, always we have to take eigenvalues, non-repeated eigenvalue. When we are substituting non-repeated eigenvalue in your system of equation, you will get three equations. The three equations are different means we can apply cross rule method. You will get a eigenvector of x1, that is eigenvector x1 you will get. Okay, and so after that, in this repeated eigenvalue I am going to substitute. When I am substituting a repeated eigenvalue in our system of equation, we will get three equations. That three equations are same means, the three equations are same means we have to take one equation. I am going to put x1 equal to 0. We will get x2 eigenvector. Okay, again you can put in the same equation x2 equal to 0. We will get x3 eigenvector. Okay, this is one model for finding eigenvector. And the next one, lambda is equal to -3, -3, -3. For example, you can take all the three eigenvalues are same. All the three eigenvalues are same. So how to find eigenvector? That's a question. Okay, the usual procedure, a minus lambda e into x equal to 0. When solving that, you will get three equations. From the three equation, I am going to substitute lambda is equal to -3. When I am substituting lambda is equal to -3, I will get three system of equations. If the three system of equations are same means, already you know, put x1 equal to 0. You will get x1 eigen vector. Okay, and again put x2 equal to 0. You will get x2 eigen vector. Next, again you can put x3 equal to 0. You will get x3 eigen vector. Okay, so when we taken all the eigenvalues are same and your system of equation also same means we can able to find like this way. Put x1 equal to 0, you will get x1. x2 equal to 0, you will get x2 eigenvector. x3 equal to 0, you will get x3 eigenvector. This is another model, type 2. Second procedure in type 2. Okay, next model. Suppose I am taking lambda is equal to 3 eigenvalues repeated, but while finding eigenvector, so you will get a system of equation 3. I am going to substitute these eigenvalues from that system of equation. I will get different eigenvector, different equation. I will get different equation. Okay, in this case you can apply cross rule method. In this case you can apply cross rule method. You will get eigenvector of x1. You will get eigenvector of x1. Remaining x2 eigenvector and x2 eigenvector, how to find? Already this is different eigenvector, different equation, so we will get one eigenvector. Rest of two we cannot able to find. Just equal to this x2 eigenvector and x3 eigenvector. This is one model. And one more term. So whether it is a repeated eigenvalue or non-repeated eigenvalue, when we are substituting the eigenvalues, the system of equation will get x1 plus x2 plus x3 equal to 0. Generally based on this. When I am substituting the eigenvalues, I will get x2 equal to 0, one equation. I will get x3 equal to 0, one equation. But in the system of equation, there is no x1 term, right? So in this type, you can consider always x1 equal to 1, whether it is x1 or x2 or x3, you can consider equal to 1. This is procedure you should know while solving problem in eigenvector. Okay, so these are all very important. Without understanding this, you cannot be able to solve eigenvector. Okay, thank you.